Okay, I have the honor to have the last speech of the day, and it's really kind of summary what I learned today, put on slides, and to launch the word precision prevention, which was indicated to me yesterday night by Carlo Lavecchia. I said we have to move in that direction. Now the thing is, what Eric already mentioned, we have seen an explosion, really a tsunami of molecular biology in oncology and in other disciplines. So, and it's difficult to cope with that, and it's really going much more exponentially than ever before. And it's not only the number of publications, the number of laboratories. Almost every university has multiple laboratories in molecular biology. But the tests are going to be extremely more complicated than ever before. We have the tests related to DNA, we have the test related to RNA and protein metabolism, and especially for prevention, we need to mention epigenetic modifications. And you know, DNA is a very robust molecule. You can study DNA mutations, polymorphisms, etc., even after 2,000 years on mummies of Egypt. And you can do it with multiple testings, and we have the genome sequencing, the whole genome sequencing, and then the exosome sequencing to make it more efficient. But you have also other tests which are more tricky and much more valuable for prevention. And I refer to microRNAs. They are extremely predictive for the actual situation of a cancer patient. And also modifications in DNA, as what Jose Russo told this morning. These areas are very interesting for prevention, along with the DNA tests. But there is a problem, and the problem is depicted here, and also what Eric just said. That is, all these molecular biology information is getting to new treatments. Very good, much more opportunities. But look at this. For a new treatment of malignant melanoma, we have to spend about 80,000 euros for a trial period of 3 months, and the response rate is not higher than about 20%. So it's a problem. Nobody can afford that. We cannot give this to all our cancer patients. The thing is, we have to select the patients. And how do we do the selection? Well, there are a number of tests. We can have tests such as liquid biopsy in monitoring treatment, very valuable, and I think that will increase in the future. We have genomic tests which can predict the response to treatment for refractive tumors, for metastatic tumors, and for very rare tumors. We have a number of them. It's increasing very rapidly. For adjuvant treatment, for example, for breast cancer, we have the Oncotape DX, MammaPrint, we have PAM50, and a lot of other products. And also this array of testing is increasingly being used. And then for quite a recent time, we see some cancer risk tests being commercially available. We have them in the genetic centers already, but we have already now commercial tests, which we can offer to the patients and advocate them. The thing is, also these tests, well, they are expensive and also very hard to afford, and none of them are reimbursed at this moment. So there's a big challenge to do in oncology. And there is one big solution to that, and that is going back to prevention, right? What we did today. This is an explication of one of the Gendia tests that we have now available. It's developed in the United States and in Belgium, and there are a number of mutations, because it's a mutational analysis available on that test. We have the issue of polymorphisms. We discussed it today, and we must consider this, that in 1999 they did a lot of tests on polymorphisms and they didn't found any relationship. More recently, in 2009, there was an evaluation of 5 other polymorphisms, and again, no association with invasive breast cancer. So there is a problem there. Recently, we have this multi-SNAPs analysis of about 80, 100, and even 200 SNAPs that are available, and that might give some hope that we can, with polymorphisms, indicate some people at high risk for breast cancer. But recently, much more interestingly, was the microRNA type of polymorphism, because it's also a polymorphism. It's just on the translational area. And you see that the microRNAs behave very different in different stages. So it might be not inconceivable that we can develop a platform with SNAPs, with microRNAs that accurately predict women of getting breast cancer. And one of them, at this moment, we found now that there are polymorphisms significantly related to a breast cancer risk, and I think we can put them on a slide and do the evaluation. There is a recent publication, I don't know, I think it's a couple of days ago, that it was 2014, we have an update 2 days ago, and we see that there is a very nice prediction in some of them with a 9-fold, 7-fold increase in breast cancer. In other words, we can conclude this day that it should be possible to select people out of the population, say, this is you're getting breast cancer, you're in high risk, you should sustain all these investigations. How we do this? It's by risk assessment on the DNA level, epigenetic modifications, and at the mRNA level, but also we can monitor lifestyle things and see if this epigenetic modification won't change again in a reversible way to a low risk profile. And that's why where the epigenomic tests of Professor Russo are coming into place, and also the HEG trial, which we did, we can modify these things and we can measure the modification. That's the important home take message today. We are almost able now to select high-risk groups in the population so that we can improve our healthcare for these people, and we are able to monitor the effect of interventions and getting the people from high risk to a low risk. That was my home take message for today. Thank you.